Alright, so this is the second video for the train body. I'm going to start by doing the holes on either side of this train. So I'll go ahead and do another new sketch and use points. Again, if you remember back to the hole videos we covered, I would prefer that you create a sketch, place points, fully constrain those points, and that way your holes are 100% correct, than to try to do it the way that I did this hole by just using your pick and place locations through the hole feature. So I'm going to place my 2 points. Alright, notice I can sketch in the isometric mode. Might be a little bit more of a challenge for some of you, but I'm comfortable doing that. So I just put the horizontal constraint to make sure they're the same height. I'm going to actually look at my Word document and see where these dimensions are coming from. This hole's 1 inch from the rear, and then 4.5 inches from the rear, and a 1/2 inch tall. So this time around, I'll go ahead and dimension it the way the document has it. So that was 1 inch. I believe this was 4.75 or 4.5. Let's double check. 4.5, and then a 1/2 inch from the top. Holes or points are fully constrained, so I can finish my sketch, open up my hole command. Now I'm looking for the information for these holes. Oops. So these holes, this leader line comes out and it has 1/4-20 UNC, depth 0.875, and then times 4. So let's break this down. Obviously, you know this is the symbol for depth. We know the depth is 0.875. The times 4 tells us that there's 4 holes with this information. So there's 2 on this side and then 2 on the reverse side. This 1/4-20 UNC is now new to you. This is a threaded hole. The 1/4 inch, or the fraction component of this reading, is the diameter of your hole. This other information tells us that there's 20 threads per inch, and then this is a clarification for the thread type. So when I do this in Inventor, right, what I'm going to start with is my diameter, which was 0.25 or 1/4. My depth was 0.875. Okay, and to make this a threaded hole, I come down here to where it says tapped hole. The operation of tapping a hole is the process of cutting threads. So when I click on that tapped hole, it's taken a second, but it comes up with your thread information. So the size is defined by the size that we put up here, or I guess it changed on me, but it does default to a 1/4 inch. Then if I look at what thread types are available for 1/4 inch, 1/4-20 UNC is actually our default. Okay. Now, what I need to change here is that the threads go the full depth of the hole. Alright, and then now I guess I got to go back in here and say 0.875 again. Alright, once you hit enter, notice if you zoom in on that hole, you kind of see the graphic for a threaded hole. Okay, now I could very easily come to my left side and do that operation again, but I'm going to start to show you work planes and how you can use work planes to make sketching, or not sketching, but make modeling a little bit easier for yourself. These 2 holes are identical on the other side. So what I can do is I can actually mirror them across the part. The mirror tool is right here. But the only way I can mirror something is if I have, a reference point that's directly in between what I want to mirror. So I'm going to come up here to work plane, alright, and I'm going to click on the down arrow, and what I need is a work plane that is right in the middle of this part. So if I scan all of these options, okay, and I read them, this one right here says mid-plane between two planes. Well, this right side of my part and this left side of my part, if I choose those two sides, I get this work plane that cuts directly through the middle of my part. And once I have that, I can now use my mirror command on those holes. The feature are those holes. I can click on them in my sketch, or it's probably a little bit easier to come over your browser and click on them. And the plane is that plane that I just created. And notice it always gives you a graphic, it always gives you a simulation of what you're doing. That looks right. I personally know that it's right. I'm going to say okay. Okay, and notice that the holes, they come in exactly where they need to be. If you notice, my browser represents the work plane that I created, and it represents the mirror that I did. Okay, this work plane I don't need to see. I'm not going to delete it, but I am going to come down to where it says visibility, and I'm going to hide the visibility of that work plane. Right? The reason I showed you that is to get this last hole, this hole right here, I do have to create a work plane. Okay? So, this hole is 0.875 inches back from the front. It's got a diameter of 0.5, and it goes a depth of 1/4 inch. Now, if you come in here and you try creating a sketch, it's not going to let you choose that cylinder. And that's why you have to build a work plane. A work plane is a flat surface. It's a plane. Sketching, in order to create a 2D sketch, you've got to create it on a flat plane. Okay? So if I come in here and again click my down arrow and I read these, alright, once I come down here, obviously I'm kind of working with cylinders so they catch my eye a little bit. Alright? This one says tangent to a surface through an edge. This one says tangent to a surface through a point, tangent to a surface, and parallel to a plane. This third one is the one that I want. If I click on this, notice my status bar. My status bar is telling me to select a curved surface or a planar surface, so it doesn't matter. I'm going to click my cylinder, then I'm going to click that parallel plane. These two would be options. The bottom is technically an option, but I'm going to click right there. That creates that plane, again, tangent to my cylinder and parallel to that reference plane. Now that I have that, I can create my sketch. I can place my point. I can dimension it just like I would if I was working on a perfectly flat surface, okay? And I can even use my geometric constraints the way that I was. So that point is fully constrained. I can now open up my hole tool. Alright, I'm going to turn this back to a regular hole. I think it was 0.5 and 1/4 inch deep, but let's check. 0.5, 1/4 inch deep. So I say OK. I don't think I did that right. It doesn't look right. Oh, I did the opposite. So I want this to be 0.25, and I want this to be 0.5. And then again, I can come back to my work plane, turn its visibility off, and that is the train body. So again, one of your requirements for this project is that you kind of go in and you do some more stuff to it. All right. You guys have already learned through the Puzzle Cube project that you can make it a different color. So maybe if I'm making this one, you know, a Farmington Knights train or something like that, I would make it black. Or if I don't like the black, maybe I can find the gold, right, and use that and start to personalize my train a little bit. Okay. One thing I want to stress with this video, since this is the first part we'll be saving, is that when I go to save, I want you to go to your Z drive, just like the puzzle cube was its own folder, I would like you to make a miniature train folder. And these parts have names, so I would use them. This one happens to be the train body. I tend to, add the overall project. So MT would stand for miniature train, and then give myself the part name. So train body, and now I have that new folder created. As I make more parts, they can all get saved there. So a little longer video for this part, but I did show you how to build work planes. I did show you how to mirror stuff, and how to do tapped holes. So there are some new commands that are making our geometry, our modeling, our parts a little bit more in-depth and complicated. So we are going to move on to the smokestack with our next video, but otherwise doing some extra features to this is your requirement.